Okay, so the APU installed on the Challenger 604 and the 605 is a Garrett APU, a 36100E or a 36150, which has got a 30 kVA generator, which is the same rating as the engine generators. Under heavy load conditions, the APU generator takes priority over bleed air loads, and it does that by monitoring the EGT of the APU. And if the EGT starts to get too high, then it will prioritize the generator over the APU, the air, and the air will be shut down. This is to ensure that we've always got electrical power available, because potentially it may be our only source of power, and we need electrical power to make sure we've got the hydraulic system working. It's automatically controlled and monitored by an ECU, which is a control unit that's completely monitoring the APU. It's looking out for any problems, and if there are any problems, it's going to shut down the APU and protect it. The APU itself is located in the aft equipment bay and is completely enclosed by a stainless steel lined fireproof enclosure. You can just see the picture of the APU enclosure in the picture on the right hand side of the text. That's got the front panel removed. Normally there's a panel in front of that. It's completely enclosed in the APU, protecting the surrounding structure, and is designed to contain a fire if there was a fire, and the fire extinguishers in the fire extinguishing system will go and be discharged into that enclosure and put the fire out. You can see the APU in its enclosure, which is in the aft equipment bay. You can see the air intake for the APU is just on the top of the fuselage, and there's an S duct that takes the air down into the compressor inlet. There's no opening doors or anything like that on the inlet. It's just an open vent intake. So the air comes down into the APU, into the compressor. The APU does its stuff, and the hot exhaust gases are discharged overboard out on the right-hand side. And on the outside surface on the fuselage, there's a stainless steel kind of protection for the heat protection to protect the paintwork. One thing, because it's close proximity to the engine, when the APU is running, you can't open the engine nacelles, or otherwise you'll damage them. To keep the APU compartment cool, you'll see a little flapper door on the left-hand side of the APU enclosure. There's a little open door there. It's got a little spring-loaded flap door. When the APU is running, air is drawn in through that flap door, circulating around the compartment internally, and it goes out through an air gap where the exhaust tube is. It's like an inductor tube, and the hot exhaust gases coming out from the APU will draw in fresh air through that flapper door to keep the APU compartment cool. There is a service door on the front panel or the rear panel of the box enclosure, and that allows you to service the APU oil and the engine, the starter generator oil. Sorry, not the starter generator, the generator oil. There's two oil systems on this APU, the APU oil and the generator pad oil, two separate systems. The generator oil is just used to cool the generator down, but it does have its own system. So you don't have to service both. They can both be serviced through that service door, or if you want to, you can take off the big front panel. If you need to remove the APU, it comes out through the aft equipment bay access door. So to facilitate that, there's a beam that's installed on some frames in the roof of the aft equipment bay with a sling and a winch or a hoist. So you attach the sling to the APU, lift it, it slides along the beam, and then you lower it down through the aft equipment bay hatch. Start for the APU comes out on the fuselage side, on the right hand side, very in close proximity to the engine nacelles. You can see the safety zones there and the different temperatures that you would expect. So as I said, there is a warning down there. It says don't open the engine cowls when the APU is running. It's a very simple machine. We just have a single stage centrifugal compressor coupled to a single stage radial turbine, a single combustor kind of can at the bottom of the combustion chamber with an igniter plug and a fuel nozzle or atomizer. So once we've ignited the fuel, it turns the turbine, which drives the compressor, and through a shaft drives the accessory gearbox. And on the accessory big gearbox, you've got your starter motor and the fuel control system and the lube pump. Then you have a generator adapter, which is attached to that, to the accessory gearbox. That's got its own integral oil system for the generator cooling. And so on the generator adapter, you've got your aircraft generator, the 30 kVA generator. Okay, for a Gen Fam level course, we don't need to go through this wiring diagram step by step and all through the nitty gritty, but I just want to highlight something here that might be useful. First of all, for the APU start switch, we've got a fuel pump switch, which turns on the fuel pump and also fires up and powers up the electronic control unit. And then there's a start switch to actually start the APU and stop the APU when we want to stop it. The one thing though that's important, the switches, power switch, the pump switch, must be switched off physically in the off position before you switch on the battery. Otherwise the ECU doesn't get powered. It's kind of a safety feature. So always make sure you turn off the APU. It should be off, the switch should be off anyway. It's only if someone's been playing with switches that it'd be in the wrong position. But make sure the pump power switch is switched off before you put the batteries on. Otherwise, it will be impossible to start the APU. It's just a safety feature built into the system to prevent an uncommanded or an unexpected start when someone flicks on the battery. Right, what we've got here is just a simplified schematic of how the ECU fits into the whole scheme of things. Obviously, the ECU is completely controlling the APU. It allows a load control valve, otherwise known as a bleed valve, to open if the crew request it through the bleed panel and it's ready to load. It controls the surge valve. Now, the surge valve takes the load off the compressor when the load control valve is not in use. It's going to basically do the opposite of what the load control valve does. So if we're not using any bleed air loads, then the surge valve has to open just to relieve some of the pressure on the compressor, and the air just is vented overboard. It's controlling the ignition system, it's controlling the APU starter motor, and it's controlling the FCU fuel shutoff valve. That's a solenoid valve on the FCU. And it's controlling the FCU torque motor for the fuel flow, the metering of the fuel. It's also receiving inputs from, for example, the fire system, which will shut down the APU automatically if there's a fire. It's looking and monitoring all of our parameters to make sure we're not overspeeding or underspeeding, making sure there's no low oil pressure in both the APU and the generator adapter. It's making sure there's no oil over temperature in the APU and also the generator adapter oil as well. And if any of those happen, the APU will shut down. There is, as we'll see a bit later, an APU fault panel on the outside of the aircraft, and we can see if we've had an unexpected APU shutdown, we can go to the fault panel and it will tell us what the reason was behind that shutdown. So here we can see our APU control panel, two switches, the master switch, if you like, the pump power switch. Turn on that, puts on the APU fuel pump, powers up the ECU, and now we're ready to start. And when we push the start button, it starts. Once the ECU is happy and everything's up and running, we're on speed, the available light will be illuminated. And that will tell us now that we can use the APU for bleed loads, and also the generator is available to come online. The APU information is displayed on the ICAS secondary page. Two simple parameters that are monitored: speed and EGT. Everything is color coded. If everything is good, it's in the green. If it goes out of limits, overspeed, for example, it goes amber or red if it's a major overspeed. Same with the EGT. Should be green is good, amber it's kind of getting into the critical area, and red, it's over tempered. APU fault panel that I was talking about earlier. It's located just behind the baggage door on the left-hand side on the fuselage. There's an access panel you can open up. Actually, if you open up that access panel, you'll see a manifold adapter to take HP air for external engine starting. So that duct will feed into the 10th stage bleed duct. But you've got your APU fault panel there. So if the APU is shut down for any reason, go to this panel, you'll see how, or the reason why it's shut down. There'll be an LED indicator lit there. There's on some panels, looks slightly different from this. Some panels have a test switch where you can test all the indicators. All panels will have an indicator reset to reset any fault indications, because the fault indications will be latched and they stay in view so that you've got a kind of record of it. And then there's also an Apu Stop Switch if you need to stop the APU if it's running from the outside. It's just the alternatives fault indication board that you have on some aircraft. Just slightly different design, really, but it does the same thing. You've got your indicator test board there to test all the indicators. You've got the stop switch. There's a reset switch to reset any fault indications, but all the fault indications are all the same. So we've got overspeed, overcurrent, EGT, high EGT, low oil pressure and high oil temperature for the APU. Same for the generator oil as well. I said earlier, the ECU is monitoring the APU, making sure there's nothing going untoward, and if there is any problem, it's going to shut it down. The APU will automatically shut down under the following conditions: a high overspeed situation, EGT, high EGT, low oil pressure, both at the APU and the generator, high oil temperature, the same, an overcurrent in the ECU, or a fire. Finally, the APU starter duty cycles. So there are two kind of starts defined, a soft start or a hard start. The soft start is when you're using the battery, the aircraft battery, the APU battery. And for that, you're allowed 3 start attempts at 30 seconds each. So 30 seconds on with a 20-minute rest period. And then 2 further start attempts at 30 seconds maximum with a 35-minute rest period after that. A hard start is when you're using external DC power. And the reason there are slight differences is because they're worried about cable temperatures rising in the electrical cables coming from the external DC. So for this, you're allowed 2 start attempts at 15 seconds with a 20-minute off rest period, and then a further 2 of 15 seconds maximum with a 35-minute off period. So it's the time the starter is motoring that's a critical thing. So for an internal start, you're allowed the maximum time. Remember, the APU starter cutout actually will cut out after a maximum of 30 seconds anyway. But for the external DC, that's reduced to 15 seconds, so we just have to monitor it. But the APU should start up. If you're doing a normal start, the APU will start up in well within that time frame. Anyway, that concludes the APU presentation. Thank you very much.